Yeah. Thank you, Scott and Matt. Thank you for organizing this. I'm really excited about the space. I echo everything that Matt and Scott said. I really think this is a really exciting field for like econ, CS, AGT, all this intersection. Lots of impact on practice. And the way I want to kind of explain why I'm so excited about this is actually to start from a bunch of skepticism. So you probably heard a lot of grand kind of like statements about Web3, blockchain, and so on. And I want to start by just thinking, what can blockchain really do? What can't it do? And I want to argue that there is something to be excited about. Even if you take all this salt, all the skepticism, there will be some things that blockchain really makes exciting. And I want to talk about directions for research, innovation, how we can make the world a better place by doing research using all of this. Okay? So let me start, as you should at this point, I think, by asking ChatGPT to define things for you. So I asked ChatGPT to tell me what is Web3, and it gave me this paragraph that basically said, Web3 is something that will make things great. It's the new iteration of the web. Not completely clear what it is, but I think it's a pretty accurate summary of what kind of like is out there. A lot of statements out there basically say Web3 will make things better without really going into the details of what exactly it is. And there are like a lot of really high expectations. Like you can see in the media a lot of statements about how decentralized ledger technology, Web3 or blockchain will revolutionize everything from healthcare to help artists. And if I want to summarize it by one sentence, I can say that like it's gonna blockchain the blockchain out of the blockchain and make it more blockchain, blockchain, blockchain. Okay? Um, so a lot of high expectations, a lot of promise, a lot of funding that goes into this, but not much is happening on the ground. And so there's a lot of suggested things that blockchain can solve. A lot of those were not solved by blockchain, at least as of now. Okay? Um, and to kind of like get a better sense of what kind of can blockchain do or not do, we need to actually kind of like answer what exactly is it? Okay? So what is blockchain or distributed ledger? Okay? So at a very high non-technical level, it's a trusted computer in the sky. It's instead of having a computer that's run by Amazon or running on my server, we'll have some computer that's running in the sky somewhere that can give us trusted storage of data, can hold our data, can execute code. If you think of ledgers, a lot of what we do online is just simply ledgers. Facebook is basically a big database that manages our data and gives it out. Well, instead of having Facebook manage it, maybe we'll have some computer in the sky managing it, and then it's going to be open and not controlled by anybody. And I'm going to talk about how this can be really useful. Like if you think of many of the services that we rely on, some of them are literally just record keeping. So if you think of payments, like services like Venmo or PayPal, they're not exactly just record keeping, but they're very close to that. If you think of all sort of repository for deeds for real estate, it's basically record keeping. Record keeping is a hugely important part of our day-to-day life, a lot of the economy, and that's kind of like the most basic functionality that it can do with a computer. If you can have a computer in the sky, it can do more stuff. You can run code on it. If the code can control some things, you can automatically do some decisions. I can what's called smart contract. I can just send code to the sky and have this code run an organization or firm or automatically execute some agreements between people. I can run some market automatically. So all of that sounds very useful. Okay? Why didn't it solve all the problems that I just stated before? Well, sometimes the problem is not the computer that we run things on. So there's a lot of examples. I ran through a bunch when I went through making the slides, but I picked this one. It's kind of farcical, but I think it kind of makes the point in a pretty good way. So there was some DAO, some kind of crypto organization that tries to employ smart contracts and kind of like its own laws and kind of like the decentralized structure to redo a movie that never happened about Dune. Like there's kind of a seminal project to make a grand kind of project to make a movie about Dune back in the 50s. It was supposed to be like this really expensive movie that never happened, but some books with a concept art came out, and this DAO, this organization, bought the book for $3 million, and the intention was to burn the book and make the entire IP as NFTs online. Now, they bought the book for $3 million. They were successful at that, but once they bought it, they realized that IP law and the rights to the copyrights to those pictures are not governed but whatever rules they make up in their code. I can write in a note that I own Virginia. That doesn't mean anything, right? Like I can write whatever I want on my computer. That doesn't mean anything. Copyright law is regulated by the courts of the United States, by the legal system of the United States. If I want to change ownership of the legal property if I want to change ownership of the copyrights to those concepts, to those drawings, I need to go through the codes, through the systems. And the binder book doesn't give you the copyrights to those. So from the beginning, that was just a very misguided project, kind of not understanding what is the scope of what's like your computer can do. You can write whatever you want on the computer. Whether it has an effect on IP rights, it's a different question. And if you want to ask it in a kind of very general, harsh way, you can say, why do we even care about the computers we run things on? So Intel had this very popular campaign, Intel Inside, from the 90s, or like, as far as I can remember, which is a very curious thing, because like generally you don't really care what's inside your phone, your computer. It's inside. As long as it's working, you shouldn't really care. Same thing, like I don't really care what is Goldman Sachs using to process my transaction. I know that it works because I don't care. Like whatever they're using, is it a Unix server or like Web3 server? I don't care. Like, it's plumbing works best when it's kind of like when it's invisible. So we need to ask, is it really useful in some way? In order for me to care about kind of like having some kind of chip or something, you need to tell me, oh, if you don't have Intel, it's not going to be compatible with some things. If you don't have Intel, it's going to break after something. Like there's something about it that you should care. And the problem of a lot of the claims that people use for like why I want blockchain in my application is a lot like stone soup. So I find this parable very useful in thinking about a lot of those projects. So let me just tell you the parable. So the story goes that a poor traveler goes through town and he tries to convince people to give him food. And the people are kind of resistant, and he tries to kind of like pitch to them that like, if you can give me food, like I can teach you how to make a soup from a stone. So obviously, once he says like I can make soup from a stone, everybody gets really excited. And then they come up to him and say, how we do this? It's like, obviously you need to take a pot, put the stone in. It's like, yeah, great. Now, obviously you need to add some vegetables in. Obviously you need to add some herbs and meat and like, and all the other stuff and water and boil for a few hours. And after you add all those things, you take out the stone and you have a soup. And when you think about a lot of the claims about blockchain, let me take just a straw man. Like one of the claims that you sometimes hear sounds like people cheat on shipping documents. If we put the shipping documents on a blockchain, people will stop cheating. Yeah? And sometimes like it's just kind of like the stone soup. The stone was completely irrelevant for the soup. Yeah? It may have been some sort of catalyst or instigator for this. But once you think about this, like just stop people from cheating, you never cared what the shipping documents are recorded in anyway. Yeah? So I think that's kind of critique that applies to a lot of what you hear about blockchain. But despite that, I want to say I'm still excited. So why am I still excited? I have like three kind of broad categories that I'm going to go from the core, from the periphery to the core. Okay? So let me start from the third one. The third one is even if blockchain is the stone in the stone soup, it's completely irrelevant. It's not really necessary to solve the problem. Maybe it's necessary to ask the question. There's a lot of things that are plumbing in this world that we don't pay enough attention to. I'll talk about payments in a bit. And payments are actually not a bad example for this too. Like payments in the US are slow and clunky, and there's a lot of examples of even large institutions having trouble with payments. I didn't have the slide, I didn't put it, but like Citibank mismanaged a $900 million debt payment for Revlon. Like Google destroy. It's just incredible how kind of the back-end operations of even big financial institutions are just messed up. So there's a lot of things that are kind of like could be solved, could be done better. Even if blockchain is not the solution, it may be good to ask those questions. And it's great to standardize shipping documents. IP law should probably be updated in many ways, even if that has nothing to do with blockchain. Great topics to work on. One kind of question that I kind of wonder is like smart contracts. Like when I asked legal scholars about smart contracts, they just said they're just contracts. It doesn't matter whether you write a smart contract or any other legal contract. If it's between IBM and McKinsey, they're going to litigate it in court in the same way. But still, why don't we write legal documents in code? No, sounds like a pretty good idea, even if it's not on blockchain. Anyway, so a lot of questions like you should ask, a lot of questions that you can just rethink about finance. There's, of course, a lot of literature about finance, but now we may have a different take on it. We may think about it in a different way. So great questions to ask, even if the solution is not blockchain. The other layer, that even if blockchain does not directly solve your problem, it may have pretty profound impacts. So I take inspiration from the 7-layer model, the OSI model. It's like the internet stack. It's kind of, I used to do communications back in the day. And one of the core concepts was that you don't solve all the problems at once. If you want to build Skype, Skype has to solve a lot of different things, like Skype or Zoom or Gather need to send images and a stream of data from my device to your devices. Well, first thing we need to do is like how to send bits, how to transfer bits in a physical space. And we need to figure out how to get those bits to the right place, how to organize them. Like there's a lot of things that go on even before we start writing the code for Skype or Zoom. And the internet stack, or like just object-oriented programming, a lot of approaches in computer science just say compartmentalize things, just build stacks. If you have TCP/IP or Wi-Fi line, you solve some kind of like some steps in the problem. Other applications can build on top of that. You can think about blockchains and those kind of financial services in a similar way. So Bitcoin or other crypto assets are not particularly consumer friendly. And that doesn't mean that they're not useful. If you have a pretty basic infrastructure for using payments, even if it's not consumer friendly, it may be helpful as a base layer for allowing other services to be able to on top of it. So like even if you can't do lending on the blockchain because they need to do all sort of like vetting of lenders, that's how to do on the blockchain, still maybe having a financial infrastructure that makes payments much more easy is going to be conducive for lending, because it's going to enable lenders to enter the market more easily. And a couple of notes, there's a couple of examples of companies, Stripe, Square, that make a lot of money. They have a large market cap of basically providing the service to companies. They help companies process payments. And one of the things that's like you want to ask, I think, is why do we need companies with large market caps to do that? Shouldn't that be just an easy thing to do? Yeah? Another example is Plaid. That's a company that allows other companies to connect to your bank. So suppose Venmo wants to take money out of your bank account, it needs to integrate to your bank. That's a difficult thing to do. Plaid provides services to make it easier. Yeah? And of course, making it easier will have a profound impact on all those other markets. Now, you can think of like making it everything more functional or all those layers easier with kind of blockchain, but it's not the only solution. Like another kind of approach is just regulation and antitrust. Like I'm gonna talk in this lecture mostly about how blockchain can help all of those things. I want to make a side note that blockchain is by far not the only solution. Like a lot of antitrust and regulation by governments and other standard-setting organizations like the Fed can have a profound impact on all of those too. So, for example, the DOJ blocked Visa from buying Plaid exactly for the reasons I just mentioned. Like Visa is not a competitor to Plaid. Plaid is not doing anything that competes with Visa, but still this was blocked because Plaid allows competitors to Visa to emerge. It makes payments more easy to set up. And the DOJ took a longer term view, said like in the long term, like that may be something that will in the future prevent competition to Visa. If we want to make payments more competitive, we should make the services that enable payment providers to start up. We need to make them open and not controlled by the big players in the market. Sorry, I forgot to say, but if anybody has questions, please stop me. I'm not reading the chat, but Matt and Scott, you can stop me and read from the chat for me. Yeah? I'm happy not to go through all the slides. Okay, so all of those are great things, but let me get now to the core. I think that all of those are great, impactful things, but the really interesting things research-wise is that I think blockchains actually do have new capabilities, new properties that can address actually important issues. And to kind of motivate this, I'm going to look at payments and the Nakamoto protocol that runs Bitcoin. So let me think of a payment system. Payment systems are a really important functionality of computers and record keepers, and a pretty simple one too. So I think it's a pretty nice one to start thinking about. And if you think of what is a payment system, it's just a computer, an Excel spreadsheet that stores balances, allows users to make transfers and updates the balances, and must be secure in some sense that you can only make a transfer if you're authorized, if you're the actual user that holds the account, and you actually have sufficient funds. If you have those properties, you basically implemented a payment system. And this is a trivial thing to do. If you just have some operator that you trust, they have an Excel spreadsheet, and they can authenticate users, that's basically it. So, FTX failed to do that, but it's not that hard to do. And the traditional solution is basically just find somebody to do that. So I could write a lot of companies here from Bank of America that gives you a digital wallet in your cell phone, to kind of like basically any kind of wallet app that you have, Visa, MasterCard, all of them. Basically, you just run databases. You have users communicate with those databases, and users have to be authenticated. You have some method for authenticating. You make sure that only you control the databases and nobody can disrupt them. And that's basically it. I'm simplifying, of course, but essentially you get a record keeper. So we have all those services. FedWire and Swift are particularly, not particularly, but pretty old ones. We have those for a long time. So if I want to say that blockchain can do something better, I need to tell you what's the problem with those. So one problem that you sometimes hear is that all those systems require trust. And especially in the early days of Bitcoin, you heard a lot of people that said, we don't like the banking sector, we don't trust them. I don't want to do that. I want to have my own system. I want to have like my own wallet and code my own database. So if you don't like those institutions because you don't like them, you don't like them. That's kind of like whatever people want, they want. But for most people, if you ask them, do you trust Bank of America? They will ask you, what do you mean? Like nobody that you talk to on the street will think Bank of America will steal money out of their accounts for good reasons. Because, of course, somebody in Bank of America can steal your money. So we have institutions to prevent this. The clerks in Bank of America have some oversight on them. Banks are regulated, audited. We have accounting firms, we have regulation, and we have also reputation. So if you're a firm, you have some reputation for being credible and not cheating customers. And on top of that, cryptography also that now helps us even more. So in practice, I would say that's not really an issue for most people. But what are issues that are kind of very prominent in payments? Well, monopolies harm and hold up. So both of them are related to the fact that once I have a record keeper, that record keeper has a lot of power. And even if they don't cheat, they don't cheat you at all. They can't cheat you, they're audited. They can still abuse this power. One way is that they can demand transaction fees for their service. And those transaction fees can be high. So I can say, well, I'm the record keeper. Unless you pay me 3% on any transaction, I'm not going to process your transaction. And monopolies can charge a price that's too high. That can lead to monopoly network loss, some welfare loss, less consumer welfare, a lot of problems. Another problem that I'm going to talk about less today, but is also very important, is the holder problem. That each one of those institutions have complete control over the system. And if Twitter decides to shut down tomorrow, what recourse do we have? Like one kind of examples. Do you want to give somebody all this power? And maybe there's all sort of inefficiencies because I don't want to commit to a platform that may change their mind later. Maybe I don't want to take some product for free now, upload all my pictures to some repository, knowing that in 2 years I'll have to start paying for this. So the fact that those platforms can do whatever they want with the platform can lead to hold up exposed and non-usage ex ante inefficiency. So I would argue those are problems. And just to give you just a bit of numbers to convince you that this is a serious problem, this is not small change. The global revenue of payment providers in 2021, according to McKinsey, was 2.1 trillion. So just to put this number in perspective, global GDP was less than 100 trillion. So 2% of global GDP goes to managing Excel spreadsheets with numbers. Now, maybe it costs a lot to run those Excel spreadsheets. Maybe you need to do anti-fraud and all sort of other things that's that we're not accounting for. But I would argue that it's unlikely that all this revenue is cost and not rents. And there's strong reasons to think that the market for payments is really not competitive. So the reason that you think that firms that are profit maximizing would actually charge prices that are kind of more socially beneficial, closer to cost, is that you think that they face competition. In competitive markets, firms will behave according to what society would want them to do. But if you have monopolies, as we all know, can do things that are very different from what society would want them to do. And payment processing firms are closer to monopolies. There are good reasons to think why they're closer to monopolies because of strong network effects. For example, there are 4 credit card networks in the US. It's very hard to start a new credit card network because nobody will take your card unless businesses accept it, and businesses will not start taking your cards unless consumers actually hold the card. And this is a very difficult egg and chicken problem to solve. Gives Visa and MasterCard and Amex and even Discover like a very strong position. Yeah? And there's a lot of antitrust litigation, a lot of regulation. You may think, oh, if we just have regulation, maybe that solves the problem. Regulation is also very costly. There's a lot of lobbying battles about what kind of regulations we have. This entire thing is associated with a lot of cost. And like the picture here is just like one example of just an article. I just Googled Visa antitrust. Of course, something came up. Okay. Yeah. So yeah, antitrust is an issue. We don't have competition. There's a lot of solutions we can have, but one kind of solution is like maybe you can have a different approach to setting up the payment system. So instead of having computers that are controlled by a firm and the firm has a lot of power, maybe we can have just a bunch of computers and kind of have sort of like Uber, right? We can have everybody have his own computer. We all bring our computers together. Together we'll become a network of computers that processes payments and does everything together. And the protocol will sort of be the rules of the game or the marketplace rules that connect both of us. Yeah? And you can think of Bitcoin as basically a marketplace that connects those two sides. Miners that provide the infrastructure that are kind of like Uber drivers, and users that get basically the same services as they get in PayPal and Venmo. Now, the analogy with Uber, I think, is a very useful one, but it's also really useful to delineate the differences between something like Uber and this decentralized protocol. They're both similar in the sense that now everybody can provide the service. Like the miners are kind of like drivers. Anybody can become a driver. Anybody can be part of the infrastructure. But it's very different in that Uber has control of the protocol, of the network, of the marketplace. Uber can say, we change the fees tomorrow. We shut down. We ban those drivers. It's all the discretion of Uber. Blockchain protocols, Bitcoin, and similar are much more like, we meet in the marketplace Tuesday, 3 p.m. It's a convention. Nobody controls the market space at 3 p.m. Nobody can charge you for showing up at the market space at 3 p.m. We're just in the city square. It's all by convention. So we can really think of those protocols as kind of like a market-based approach to implementing new services. It's a protocol that sets the rules, allows the actors to kind of like engage within those rules, and hopefully create a platform or a service through that. But all the actors will follow their own best interest. A firm is a lot like a command and control approach. There's going to be one actor that controls everything, and that actor will have disproportionate power and may be able to abuse this power, like monopolies abuse. Yeah? The pictures, by the way, that I have on the side are a bunch of references that are interesting readings. Like this is if you Google, like I don't have the link, but if you Google it, this is a very interesting article to read that's very much related. Okay? Yeah, so how can we make this decentralized marketplace to provide us a payment service? Well, here's an early version. Yeah? Anybody recognizes? I hope somebody recognizes. Yeah? So this is for Monty Python, the Holy Grail. King Arthur comes and sees the peasant, and the anarcho-syndicalist commune, they're taking turns to be executive officers of the week. They don't have a king. They just take turns who gets to be the leader, and there's some like oversight of that leader. Basically, a system without a king. So this is kind of funny, but it's also funny because like when you know distributed system, this sounds really like a distributed system. So of course, like there's profound challenges that you need to do when you kind of like not have a king, and you need to solve this. let me just list them and kind of go back to the peasants to how kind of like those ideas can actually help us solve this. Okay, and that's will get us to what are the technical challenges here, and kind of like combination of theory fields that will actually come up to enable Nakamoto, as well as like the really research questions that we have to work on next, I think. So the first kind of problem here is that we have a bunch of computers. Each one of them can process transaction by himself, but how do we make sure that they all agree? How do we make sure that we have a network of computers that act as one? That, like, we need to have one ledger, one agreement on this. If we make it act as one, how do we make sure that nobody became king now? That nobody is just like the old firm, that nobody has disproportionate power? Because like the entire point, we wanted to get rid of a firm that manages things. We don't want to make a more complicated structure that will just give us another manager, another monopolist. And of course, when we do all of this, we don't just want to agree on a ledger. We want to agree on a ledger that only has legal transactions. Somebody also has to do other work of vetting transactions and all the other stuff that the record keeper did. So first bit that kind of helps us solve the problem is just cryptography. That's around for a long time. So digital signatures, cryptography is super useful, and at the very least, kind of like blockchain kind of just shows us how useful cryptography is. When somebody wants to send a transaction in Bitcoin, they say, I'm the holder of account X, I want to send money to account Y, the rest should go into account C, that's the fee, and all of this will be signed cryptographically. The cryptographic signature proves, or is the definition, that I'm actually the holder of account X. So that kind of gives us a transaction that anybody who reads this transaction can verify this is legit. This cannot be forged. If we had a big stone, a write-only ledger that everybody can write to and everybody can read, together with cryptography, we can basically now do a payment system. So if you want to just make a payment, just write it on the wall. People can just read the entire ledger on the wall, or the sequence of transaction, verify that each one of them was signed and authorized, see the balances of everybody by just reading the entire open ledger, and see that everybody had proper balances and all the accounting rules were satisfied. So the real challenge that blockchain now has to solve is, how do we get the stone? How do we make sure that we all see the same ledger? Once we go to a distributed set of computers, that becomes a real challenge, not only because we just want to manage it, because of course people will want to cheat and say, oh, like I showed you that they paid this transaction, but it didn't actually go written on the stone. Once we don't see the same stone and we don't know whether something is written or not, that opens a lot of possibility for cheating. So how do we make sure that we really all see the same stone? That brings us to the consensus problem. So going back to distributed computing's work by Lamport and others in the 80s, they basically asked, can I get a collection of different computers to act as one? At a high level, that's kind of like the question that this literature tried to solve. Can I get a bunch of computers to act as one computer, hold one ledger? Can I think of like this ledger as being one ledger, despite the fact that there's no one ledger? There's copies in many different places, but they all should sync together. In our version, we can think of kind of like a very similar motivation and kind of like extra motivation for this. We want to have a ledger that's collectively operated by a bunch of users. And the classic motivation was, well, maybe some of the nodes will malfunction or fail, so we want to make sure that it's in a bunch of computers, not in any particular one of them, because any particular one can be subject to failure. The new motivation that we have from decentralized system, from open system, is that, well, maybe some of the actors may be malicious. Maybe if a failure of one of them destroys the system, this kind of actor will have disproportionate power. So I want to make sure that I'm not kind of like subject to the whims of any particular actor in the system. Everybody is replaceable. Everybody can compete with each other and can be replaced. Yeah? So this is a very challenging thing to do. How long do I have, Matt, Scott? I don't know if they can tell me.
You can keep going. I think we reserved until 11:45, and then we have a 15-minute break. So maybe if you want to talk for another 5 plus a little minutes, and then we can take questions during the break.
Okay, so let me go through this quickly, like just to explain part of the challenge here. There's an example that I think is really useful. So there's a story, that's the Hollywoodic version. Like there's some version of this is true that's more boring, but let me give you the Hollywoodic version. When Lamport went to NASA, he saw that they have a probe like that was supposed to work for really long. They said, we want to have 3 computers on it. So if one of them fails, the system will still work. And the way we do this is the 3 computers are going to vote. Each decision they make is going to be a vote of 3 computers. If one of them fails and gives the wrong answer, the other 2 will still make a correct decision. So the vote will still be correct. Lamport took a closer look at the design and says, no, it's like your design doesn't work. It's possible for one of the computers to fail and the system to fail. And it proved actually an impossibility result too. It's impossible to build a system that's resilient to failure of one of the 3. And the real insight that you get from this example is asking yourself, what's wrong with the voting? Voting seems to work here, right? 2 out of 3. Well, the problem is, who does the voting? We don't have an objective voting machine somewhere. The voting needs to be done by some of the machines. And you need some guarantee that when I calculate the votes, I don't calculate in a wrong way, or even that if I try to calculate the correct way, maybe I get a different answer than some of the other computers. Yeah? So this is a big challenge here. And there's a lot of literature here, a lot of really cool theory that has a profound impact on practice also, very close to practice. It's a beautiful literature that unfortunately I can just tell you about now. Let me not get into this. Let me just tell you that Bitcoin was also an innovation in distributed computing, and it kind of gave a new way of solving the problem. And very roughly speaking, the way that Bitcoin solved the problem is that there's some way to randomly choose somebody, and this randomly chosen somebody called miner will get to propose a block, propose some update to the ledger, and everybody else will verify that this proposal is actually right. There's a lot more details, but at a large level, at a high level, Bitcoin just allows a totally anonymous miner can freely enter and exit, and just if you do the work and you get selected, then you get to propose and people will verify and see whether your proposal is good or not, and then everybody will agree, oh, we go with this proposal. Okay? So without going to the details, let's just say that this allows miners to be completely anonymous, enter and exit at will, and this is an incredibly useful property. So in some previous work, kind of like actually the reason that I got interested in this is that we thought about transaction fees in Bitcoin. Who sets transaction fees? And together with Guru Huberman and Siamak Walami, we worked on this and realized that actually nobody can set transaction fees in Bitcoin. Even if you try to do something to affect transaction fees, even if you're big, the fact that other miners can enter and exit and kind of replace you creates enough competition within the platform that nobody can set prices. And you don't even need competition with other payment providers. There's just competition within the platform itself that just removes the power of the operators of the platform. So this is a very strong property. And that kind of says, oh, we can have systems that are not controlled by the operators. We kind of separated who runs the payment system and who kind of has power to influence how much we pay for that. And you can see a really strong example of this on the Ethereum fork. Ethereum decided to move from proof of work to proof of stake. Basically, what they said to the miners, your services are no longer needed. You ran the system so far. Goodbye. Okay? You don't own the system. The community does. Your service is no longer needed. You're not going to get paid. Of course, the miners were not happy about this. And they said, we're going to fork. We're not going to agree with what the community does. We're just going to do what we do. But it didn't quite work. So here you see the price of the coin they try to fork to. And you basically say, okay, miners can do whatever they want. They can operate a different system. But the community will just decide this is worthless. This is not a coin that's useful. Nobody will buy the coin. Nobody will use it. It's also an example where there's a lot of things beyond the protocol itself that kind of play an important role in this space. Yeah? So it may be a complicated example to bring in, but I think it's a really strong example that the operators of the system do not have control of the system, and that's a really strong, useful property. So I see that I'm basically at time. Let me kind of like say kind of just a couple more notes and close. Okay? So I said one thing that Bitcoin does that's I think is a great property, like the fact that you can avoid monopolies. I see that as like a really strong promise of Web3, decentralized ledgers, blockchains, what have you. Like the promise of doing protocols that satisfy the common good, that are public infrastructure. That's like something that is hard to do without a benevolent institution. Of course, we can put things in the Fed and hope the Fed does the good thing for society. But this is a really market-based approach that is supposed to, or can be set up to do the thing that is best for society, for welfare, for consumers. It's also really technically interesting. There's new challenges that come up from running things in this environment, and I think teams work on EAP 1559 on transaction fee mechanism is a great example of this. Once you try to run things in this environment, you get a lot of the old incentive problems, but you also get new ones. And there's really nice work by Chang'an Shi and Elaine Shi that's, I think, talking next, right? That shows like you get impossibility results, and we need some creative solutions for what are actually good solutions in this decentralized environment. And sometimes you need to think about things beyond the protocol itself and try to think about how to design an organization that will be able to do upgrades or promote interest of future users or many other things. There's a lot of kind of questions beyond just the narrow protocol design, the narrow mechanism design, organizational structure, and also a lot that we can learn from institutions that failed or succeeded in getting a social mission and providing a public good in a very successful way. So I think there's a lot of promise here. I take a lot of inspiration from thinking about open source software. You can think of Bitcoin as basically an open source software. It's something that just somebody put online. There's open source contributors that update this, but it's more than just Linux and Python, because it's not just a standalone software. It also creates a community. That creates a lot of challenges for Bitcoin, because Bitcoin cannot be different versions of Bitcoin to different people. Like it's perfectly fine if I run one version of Linux and you run a different. Well, Bitcoin, no. We need to actually have some mechanism to make sure that we all agree on one protocol and one marketplace. So that introduces a bunch of challenges. But it also gives us a bunch of tools and opportunities. Because in Linux, there's no built-in monetization. In Bitcoin, there could be. There is, right? Some built-in monetization and compensation schemes. Like there's more things to work on. Like, we get to design a marketplace with all the challenges and benefits of it. And I really think that designing those decentralized protocol is market design in the most literal sense, right? You literally design the rules of interactions of different actors. So I think there's really exciting, promising directions for research, innovation, impact on society here. And I'm just going to list a rehash of like the three kind of like categories that I said before. I think all three are really exciting. I hope to see a lot of research about them. And let me just say that, like as Matt said, like it's not an easy space to get into. There's a lot of intersection of different fields, and there's a lot of difficulty just Googling and finding the right answers. So let me just suggest, if people are interested, I taught a class. I'm happy to share my materials. Email me if you want. Elaine has a great book online. Tim has a great course online on YouTube and a great class that he taught. So there are resources. If you're interested, reach out. Okay? And thank you all for the time. And I'm happy to stay and get questions.